Hey guys, this is Mr. H. Hey, I'm going to do question number 29 from the June 2024 Regents exam. This is a completing the square problem. And unfortunately, we didn't really get to cover completing the square. We just worked on the quadratic formula. But I'm going to do this using the completing the square and show you how to do that. So this is going to be one example of completing the square. At the end of this video, I'm also going to have a playlist of some other examples of completing the square that you can go watch if you want to see this done, some other examples. All right, so let's go. So we're going to use completing the square to solve this quadratic. We could use a quadratic formula, and in fact, if you did use the quadratic formula, you could get 1 point if you solve it correctly. But we're going to use completing the square. Now, the other thing that we need to pay attention to is when it says exact values, that means they don't want decimals. They only want fractions. They don't want decimals. They don't want, they don't want decimals. So here's what we're going to do. I'm going to write this equation. It's x squared plus 10x minus 30 equals 0. Now, the very first thing we're going to do is we're going to move the constant, the negative 30, to the other side. So we're going to add 30 to this side, add 30 to this side. And what we're going to have is, on the left-hand side, we're going to have x squared plus 10x. This cancels out, equals 30. Better 0. All right, now, the key for completing the square is you always focus on the middle term. You're going to divide it in half, so you're going to divide it by 2. So 10 divided by 2 is 5. Now, what we're trying to do is we're trying to put a number in here to give us a perfect trinomial that we can factor. That's the whole goal of completing the square. And the way we're going to do that is we're just going to square this number. So this is going to be 25. And that's the number that we're going to add to the left and the right of this equation. Now, let me show you. So I'm going to add 25 here. Now I've got a perfect trinomial, but I can't just add 25 to the left-hand side of the equation. I also have to add 25 to the right-hand side of the equation to keep it in balance. Okay, so now on the right-hand side, this is going to be 55. On the left-hand side, we can now factor this, and it's going to be x plus 5 squared. Now, I'm just going to show you this real quickly. If you square this, x plus 5, you'll see that you'll get this trinomial. So let me put the exponent. So this is going to be 1, 5, 5, 25. I always do the numbers first. And then you just add the exponents on the variable. So this is going to be x squared. This is going to be x to the first. This is going to be x to the first. We combine like terms. 1x squared plus 10x plus 25. You can see that that matches this. So, okay, I just wanted to show you that. That's basically what we're doing. Now, all we're going to do now is we're just going to solve for x, and we're just going to use inverse operations. So the inverse operation of squaring is to take the square root. What I do to the left-hand side, I have to do to the right-hand side. So this is going to cancel out. So we're going to have x plus 5 equals the square root of 55. This is not a perfect square. They don't want decimals, so we are not going to calculate it. We're just going to leave it as 55. But it's going to have a positive root and a negative root. So here's what we got. And then the last step is to move this plus 5 to the other side. And so we're going to have x equals a negative 5 plus or minus the square root of 55. Now, we've got our two roots here. So one of the roots, I'm going to go ahead and write it out, would be plus 55. And then the other one would be a negative 5, minus the square root of 55. But these are our answers. You could leave it in this form. All right. So remember, the goal is move the constant over to the right-hand side, take the middle term or the linear term, divide it in half, and then whatever that number is, square it, and that's what you're going to add to the left and right side of the equations. And then you you factor the quadratic, and then you go ahead and solve it. That's what completing the square is. And as I said, I will have a link to some other examples so that you can watch something else to make sure you understand this. But for now, I'm going to go ahead and sign off and post this.